review for numbers 1 through 15 of the big Keystone review packet. So numbers 1 through 5 at least deal with comparisons between numbers. As you can see, it says up here, represent or use numbers in equivalent forms, integers, fractions, decimals, so on. So one of the most common ways to do that is to look at a list of numbers written in various formats, like you can see here, and decide, as you can ask here, from greatest to least. So what I would suggest is the most common comparison to do is to turn them all into decimals. So keep in mind that the final answers here are written in the way the original numbers were written, but it would give you some idea of how to write these if you needed to order them in one way or another. So we have 8.4 with a bar over the 4, and that means the 4 repeats. But it's a decimal already, so we really don't have to do anything with it. You should be using a calculator. You know, something like this one is all you really need, but you can use a graphing one or whatever. And change all these other ones into decimals. So you change a fraction into a decimal by dividing the top number by the bottom number. So it would be 25 divided by 3. And this one is 8.3 with a bar over the 3. And square root of 72, we can just enter that right into the calculator and see what we get as a decimal. It comes out to 8.49. And finally, 35 divided by 4 in a calculator is 8.75. Okay, so we have the decimal equivalents for all 4 numbers. So if we're going to order them from least to greatest, then, or excuse me, from greatest to least, we would say, well, the one that's 8.75 is the greatest, so 35 over 4 is first. And then the next greatest one would be 8.49, or square root of 72. And then 8.4 with a bar over it would be the next greatest. And then finally the lowest one is 25 over 3. Like that. So we just need to match up which one of those has that as the answer. It looks like it would be answer C. So then another way to compare numbers would be that they ask you to do it with inequality symbols. So you need to recognize that you're supposed to figure out what symbol of these 4 you could write in here that would be true. This one's pretty easy. I think you guys probably know that 3 over 4 as a decimal is 0.75. So really what we're saying is negative 0.75 and negative 0.75. They're actually identical, so the symbol here would be equal to. But again, if you don't know what this is as a fraction, you could always take 3 divided by 4 and you would get 0.75 on your calculator. So here again, it's another comparison, and once again we ought to turn them into percents. So I guess we need to look at them and say, well, which ones are the biggest ones? If we have 0.46, that's a decimal. Let's turn 104% into a decimal. Maybe you guys know you just move the decimal point 2 places to the left to turn it into a decimal. This will be 1.04. And then if I take 5 divided by 14 on the calculator, I get 0.36. So what we really know is that the order of these things is 5 over 14 is the lowest, 0.46 is in the middle, and 104% or 1.04 is on the end. So we need to make sure we read this thing the right way. This one says 0.46 is less than 5/14. That's not right. Okay. This one is written backwards, so you need to watch how you read these things. It says 104% is greater than 5 over 14, but then it says 5 over 14 is greater than 0.46. We know that's not true, right? Because 5 over 14 is less than 0.46. So it's not this one either. Let's look at this one. This one says 104% is greater than 0.46. We know that's true. And 0.46 is greater than 5 over 14. Again, we know that's true also, right? 0.46 is bigger than that one. This one sounds like it's the right answer. Here, this one says 104% or 1.04 is greater than 0.46 and less than 5 over 14. That's no good. So it's definitely C. So you have to really be careful of how you read these things. You know, just because you write it in one way doesn't mean that they put your answer in that exact same way. You need to know what your answer means, which is that 5 over 14 is less than 0.46 and that one is less than 104%. So if you read it backwards, you get C. Alright, let's keep going. Which list of numbers is in order from least to greatest? So again, they give you one that's not exactly easy to do, but we're looking for something that goes from the lowest to the highest. So it sounds to me like we need to know what the decimal equivalents of these are. They make it a little bit easy because all of them are the same numbers, just written in different orders. So let's take square root of 5, for example, and give a decimal value for it. Looks like it's 2.24. And square root of 32, which I think we know is a lot bigger than that, square root of 32 is 5.66. Okay, so our numbers are 2, then 2.24, or square root of 5, and then 3, and then square root of 32 is the biggest one. So we needed to go from 2 to square root of 5 to 3 to square root of 32. That's C. Okay, number 5 says complete the comparison below. So we have 16 over 17, and how does that compare to 99.8%? Well, 16 divided by 17 is 94.1, or 0.941. This is 0.998. So 16 out of 17 on a quiz, for example, would be a 94.1%. I think we know that's less than 99.8, so it looks like our answer is C again. Okay, let's keep going. We'll do the first 15 questions in this video, and we'll keep going in 15 question increments the whole way. Alright, so the next skill level looks like they test you with is how to simplify a square root. Simplifying a square root doesn't necessarily mean to give a decimal answer to it. It means to write it in its lowest square root form. So the square root of 243 is a pretty big number. There must be some perfect squares that divide evenly into that. So one method to do this would be the algebraic way. The first thing I would suggest is find a list of perfect squares. 1 times 1, 2 times 2, 3 times 3, and so on, all the way up to maybe 12 times 12. So I'm going to make that list of all the numbers that have easy square roots all the way up to 12 times 12. So those are all the easy square root numbers all the way up from 2 times 2 to 12 times 12. So we're going to use those to help us figure out how to simplify the square root of 243. So for our basic problems like this, where it's just asking you for a simplified square root, there are two ways to do it. There is the sort of calculator way, which is to type the square root of 243 on your calculator, and that is a decimal that is 15.59. Which means that the answers down here have to be equal to 15.59. So it's obviously not A, and it's not C. If we type 81 times the square root of 2, you get 114.55, which is clearly not B either then. So just to show you how it works using a calculator, this one is 15.59. It's the same decimal as my original answer, so it's D. You can use the decimal way of doing it like this, but it really is only useful for very, very simple problems like these. If you have anything more complex than this, as you'll see a little bit later, that isn't always going to be the easiest way to do it. But in this case, it probably is the fastest way, and it's surely guaranteed to work. So I showed you how to do the decimal one for number 6. Let me show you the algebraic way to do number 7. What I'd be looking for in number 7 is to split this into 2 square roots. The first one would be an easy square root, which is one of these numbers. So I'm asking myself, what is the biggest one of these numbers? It has to be the biggest one that divides evenly into 162. The answer to that is 81. 81 goes into 162 2 times. So I split it into 81 and 2, like this. See, the thing is, I can do the square root of 81, which is equal to 9, and this square root of 2 I can't do, so it just comes down. And this is a simplified version of that. So it's this one. We could have done the same thing with number 6. by the way, it would have been 81 times 3, and we would have got square root of 9, or excuse me, 9 times the square root of 3. But so you see the decimal way to do it using the calculator, and you also see the way to do it algebraically. So it's up to you as to which one you want to use. Typically, I try to use the one that I think makes the most sense for that problem, whatever one I think would be faster. Most of the time for these basic ones, I would say go ahead and use the calculator. What's the decimal equivalent of 640 square root? So hit second function, 640 square root, and this comes out to 25.3. So I look through these and I say which one of these will be equal to 25.3, and I start typing. It actually looks like the very first one, 25.3. Must be this one. So again, if you wanted to split it up, I would say that the number that goes into it, if you did it algebraically, would be 64 times 10, and then that would be 8 square root of 10. So either way, you end up with A as the answer. Okay, once we get to number 9 and 10, they really kind of up the difficulty of these problems, I believe, quite a bit. It says which value of x makes the expression 3 square root of 53x equal to 21 times the square root of 53. Okay, so this is how I would approach this. I would look at this and say, well, for it to be 21 times the square root of 53, if you made that a bigger square root, meaning like you did what we did here, if you did this process, but you did it in reverse, you would actually say, well, I would normally square this number because it would be the square root of some bigger number that would give me 21. Like I would have split some really big square root into this. Let me write it over here for you. So this was like my final answer, right? So if I was doing this algebraic method, my final answer would look like this. So what I want to know is what were the two square roots that I split it into originally. It would have been 53, and then 21 squared is 441. Like that. And so the original square root would have been these two things multiplied together. One really big square root would have been 23,373. So what I need to do is make this thing somehow equal to that again. So I need to know what number would have been under there. So here's how I do this. I start with 3 square root of 53 times x. Alright, now I know that the square root I would have gotten to be 3 would have been 9. So I'm working backwards, you see. Okay, well, if I were to take 9 times 53, I get square root of 477x. So the question is what does x have to be to make this number 477? Sorry, excuse me, I was writing off the page there. So again, just to reiterate what I did there, I take this 3 and I turned it back into what it would have been. It's the square root of 9. And then I multiply these back together like I did over here, working in reverse. And what I'm saying is 477 times some number x needs to equal this big number. So essentially what I'm solving is 477x equals 23,373. And I just divide. And I get x equals 49. So it's weird because I'm working backwards to get to that solution. That's definitely a higher order thinking problem. That is a tough one, but it can be done. Number 10 is a similar idea. It says the expression square root of 85x should be further simplified for which value of x. So it's saying if you put a number in for x, which one of these numbers would you put in for x to be able to simplify that square root at all? So the only way you can really do this is sort of a trial and error thing. If I take square root of 85, and I'm going to pick the smallest one first, I'm going to try this. What if x was 3? then what I'd be saying is square root of 85 times 3. 85 times 3 is 255. So the question is do any of the perfect squares divide evenly into 255? I think, unfortunately, that answer is no. I don't see anything, so I don't believe this is the correct answer. So we go to the next one, and we say the square root of 85 times 59. That's the square root of 5,015. So could that number have a perfect square involved in it? So I check. So I'm just doing a lot of checking, a lot of trial and error here. And I went through all of my common square roots, and I don't see this one being an answer either. So we try the next biggest one. What a pain this problem is. It's a lot of work. If we did that one or the last one, if we did it, we can check them both, I guess. Well, just on a hunch, I tried this one first, and it turns out that if you take this one and divide it, it splits up into 25 and 799. So you could simplify this to 5 times the square root of 799. Let's see. So what I did was trial and error with all of these, right? I couldn't find any numbers, any perfect squares that went into 255, and I couldn't find any that went into 5,015. I couldn't find any that went into 7,990. But when I finally got to this big one, taking 85 and putting 235 in for the x, I got 19,975, and I checked it, and 25 is a perfect square that goes into that. So it could be simplified if x was 235. That's the question it's asking you, is which one of these values could you put in for x where the square root could actually be simplified? The answer is D. That's a tough one, guys. I don't know that I would say there's going to be too many of those on there. If you could focus on the ones from, say, up to number 8 and even number 9 a little bit. Number 10 is pretty nasty, but it can be done. It's just a lot of trial and error. I would guess your square root problems are going to be mainly like the ones up to number 8. Alright, let's move on to the greatest common factor stuff. For Algebra 1 class, this is what we've been working on most recently, so hopefully this should be pretty easy for you. The key to greatest common factor is very simple. Find the lowest exponent for each common variable. So I look through this and I see that there is an x in both, and what's the lowest exponent? X squared. There's a y in both, but the lowest exponent is a y, just a plain y. And there is a z in both, but the lowest exponent is a z squared. So I need to go over here and pick the one of these that says x squared, y, z squared. Well, it looks like D is the only one of those. The way the 6 comes in is because 6 is the biggest number that goes into both 12 and 78. But most of the time you can work it out with just the variables. Same concept here, right? I look at the variables and I see there is an x in both, but the biggest one is just a plain x. I look at the y's and I see there's a y in both, but the biggest one is a y squared. And there's actually not even a z in either one, in both, only in this one. So I won't even put a z here because I can't take a z out of this expression. So the common factor variable-wise is xy squared. And again, you can see that narrows it down right away to c. And the reason why the 7 is there is because 7 is the biggest number that goes into both 21 and 77. Greatest common factor problems can be very, very quick. So least common multiple is almost the exact opposite of greatest common factor. Least common multiple, or LCM as it's often called, you do the exact opposite. You look for every variable and you look for the highest exponent of each variable. So you look for highest exponent of each variable. Highest exponent of each variable. So I look through and I see x's, but I see x squared. So x squared is the highest. Y to the fourth is the highest. So already we're at D. But just so you understand where the number comes from, you're looking for the smallest number that both 9 and 5 go into evenly. The smallest number that 5 and 9 both divide into is 45. But as you can see, it's the variables that are the key to this. What are the biggest exponents on each variable? So in this case, it's u to the fourth, v to the third, and w to the fourth. So then I look over here and I need one that says u to the fourth, v to the third, w to the fourth. And that looks like it is A. And again, the smallest number that both 18 and 30 would go into evenly is 90. But as you notice, I figured out the answer without even worrying about the number in front. But it's always a good idea to know how you do that number in front. Alright, let's look at this one again. Least common multiple. So I'm looking for the biggest variable or biggest exponent. So I see x to the third, x to the third, x squared. So x to the third, y to the third, y to the fourth, y to the third. So y to the fourth, z to the fourth, z to the fourth, z to the third. It is z to the fourth. So I'm looking over here, I need x to the third, y to the fourth, z to the fourth. Looks like maybe D. Yep, D is the only option. And again, 45 is the biggest number that 5, 15, and 9 all go into evenly. So your answer is D. Okay, we're going to stop the video there.